So for this lab, what we're going to be doing is we're going to try to figure out the best ionic compound to use to design a hand warmer. Now, the two factors that we're going to consider when designing our hand warmer is which one gives us the biggest temperature change, but also which one is the most cost effective. So we're going to be looking at both of those things when we're doing our calculations. Now, in order to figure out which one gives us the biggest temperature change, we're going to be using our calorimeter. So the calorimeter, there is a beaker inside, and then there's a styrofoam lining because this is going to serve as an insulator. And then you can see that I have a stir bar at the bottom of the beaker because I'm going to place this on a stir plate so that when I'm measuring the temperature, I'm getting even mixing throughout the solution. Now, before we start adding different ionic compounds and seeing which one gives us the biggest temperature change, we first want to determine what the heat capacity of the calorimeter is. And in order to do that, what we're going to do is we're going to mix some room temperature water along with some water that's being heated. And then we're going to see how much the temperature changes after 20 seconds. And that's going to allow us to calculate the heat capacity of the calorimeter, so that any heat that gets absorbed by the calorimeter as opposed to the water inside is going to be accounted for. Now, the lid for the calorimeter, there is a hole here which allows the temperature probe to sit inside, and then I have this connected to my lab class so that I can monitor the temperature. So the first thing that I want to do is record the temperature of the room temperature water. So I just simply put the temperature probe in, and that's reading at around 23 degrees, so 23.3 degrees Celsius. So I'm going to go ahead and add 50 milliliters of this room temperature water into the beaker. And then this next part, I'm going to need to move quickly because in order to measure 50 milliliters of the water that's being warmed, I need to measure it out quickly, record the temperature, and get it inside the calorimeter as quickly as I can, because I'm going to be losing heat as it sits inside the calorimeter, inside the graduated cylinder. So I have to, like I said, move somewhat quickly so that the temperature that I measure of the water when it's in here is also the temperature of what's going on inside the beaker as well. So I'm going to go ahead and take this off. Let's get this already in here. So I have to give this a few seconds to equilibrate, but it's reading at 59.5. And then I'm going to go ahead and get this in here, turn on the stirring, and then turn on my timer. And so I'm just going to wait 20 seconds and then record what the temperature is after 20 seconds. Okay, so 39.4 degrees Celsius. So that's what I'm going to record in my data table. And then I will use the two temperatures of the room temp and the warm water, as well as that change in temp, to be able to determine the heat capacity of the calorimeter. Now, for the second part of the lab, what I'm going to do is I am going to add magnesium sulfate, which I already have weighed out here in the weigh boat. I'm going to add that to the calorimeter along with 100 milliliters of deionized water. And I'm going to see how much the temperature changes and record that temperature change. So right now I'm getting the initial temperature of the water, which is 23.2 degrees Celsius. And then I'm going to monitor the temperature while the magnesium sulfate and the water are being mixed together and see, well, does the temperature go up or does it go down? And then how much does it go up or down? I want to record that maximum temperature or minimum temperature depending on what happens. Because we're going to be testing a number of different solids. The goal is to make a hand warmer. So obviously if the substance we add makes the temperature go down, that would not be a good hand warmer. But we are going to be testing 6 different substances, and some of them will have a temperature change where it decreases as opposed to increases. So we just want to be recording either the maximum or the minimum temperature in our data table. So what I want to do, because again, you want to try to move quickly here, that as soon as this is added, I'm monitoring that temperature. I'm going to start with the water already in the calorimeter. And already stirring on my stir plate. So that way, as soon as I add this into the calorimeter, I'm going to be able to monitor the temperature as quickly as possible and observe that maximum or minimum temperature change. So as I said, I've already measured out 5 grams of magnesium sulfate. I've recorded that mass in my data table as well. So I do see that the temperature is increasing, and I'm looking for it to stabilize to see how high the temperature gets. So I'm already up to 27 degrees. I started at 23. And it's still increasing, but it's starting to slow down a little. Still going up a little bit. 20.9. Nope, now we're up to 29. So again, still going up. We want that maximum temperature. All right, it looks like we've hit that max. So now it's reading at 29.3. And you can see now it's starting to go back down a little bit, but that 29.3, that was the maximum temperature. So that's what I would want to record in my data table. And then now that I have that, I can clean off my temperature probe. I am going to use my magnetic wand to retrieve my stir bar because I don't want to lose that down the drain. And then I'm going to clean out this beaker and then do the same process again with each of the ionic compounds and see again which one is going to give us the greatest temperature change, since we're looking for a hand warmer. And then with the calculations, we'll talk about the cost of each compound, and so which one would be the most effective in terms of the change in temperature, but also the price of the compound as well. And then we'll see which one would make the best hand warmer.